This is Brittany Hytrek and Mick Schwartzendruber's problem.
So we start out with the problem statement saying that we're going to be solving for delta 1 and delta 2, and we look at the object we're going to be solving for the change in length for, and we see that this has to be an indeterminate problem because of the fact that it's between two fixed walls. So we can start out knowing that we're going to be solving for the change in lengths due to the force Q acting down on the circle, which is the circle's weight. And then we can plug in that these must be putting out reaction forces in order to compensate. So we can go ahead and start setting up the problem in the fashion of an indeterminate problem by starting with our force balance. And we just know that RA plus RB minus Q equals 0 in order so that the signs for the reaction A and reaction B can be solved for later. And then we follow with the equations for the change in length dependent on the flexibility. So delta A equals the flexibility of A times the reaction at A, and delta B is the flexibility of B at the reaction B. And we finish it up with our compatibility equation, knowing that because this object is between two fixed walls, the overall change in length must sum to be 0. So from here on out, it's algebra. We're going to be solving for delta 1 and delta 2. And so we just start plug and chug. So we're going to start out by combining equations 2 and 3. So we can do FA-RA plus FB-RB equals 0. And I'm going to go ahead and solve for RA. So we know that it's FB-RB, of course, don't forget the negative, over FA. And then we're going to plug that back into equation 1. So we know that negative FB-RB over FA plus RB minus Q is equal to 0. And if we isolate the Q, we can solve for RB. Here. And we can go ahead and plug that back into equation 2b up here, knowing that delta B equals FB RB. So delta B is equal to Q over 1 minus FA over FB times the quantity of FB. And we pretty much do the same thing to solve for delta A, except we can take our known equation for RB and plug that back into this one for RA. So we have that RA is equal to negative FB RB over FA. We multiply that by Q over 1 minus FA over FB. And knowing that delta A is simply FA RA, we can solve that delta A is equal to negative FB RB over FA times Q over 1 minus FA over FB times FA. FA's cancel, and we're left with our equation for delta A.